So have you ever run into this? You build an application, it feels lightning fast for you and your local team, but then you start getting complaints. Users on the other side of the world say it's painfully slow. You've tuned your database, you've optimized your backend, but the experience is still just lagging. It's a super common problem, and it can actually cost you users. Today, we're going to dig into why that happens, and more importantly, how you can fix it for good.
Okay, let's just look at the raw numbers here because they really tell the story. Let's say your main server is sitting in Virginia. A user nearby, they get your content in a snappy 40 milliseconds. Awesome, but look at London and Tokyo. We're talking 800 milliseconds. That is a huge difference. For a user, that's nearly a full second of just waiting for something to happen. In a global market, that's a deal breaker.
So what's the deal? Is your code just bad? Nope. The bottleneck here is literally physics. When someone in Tokyo requests a file from your server in Virginia, that request has to physically travel under the Pacific Ocean, hop through who knows how many different networks, grab the data, and then make that entire journey all the way back. You're basically fighting the speed of light.
All right, so if we can't make light travel faster, and trust me, we can't, then the only other option is to shorten the distance. We have to bring the content closer to the user.
And that brings us to the hero of our story, the Content Delivery Network, or CDN. Think of a CDN as a massive worldwide network of servers. Its whole job is to take copies of your files, your images, your videos, your code, and store them in data centers all around the globe. So instead of forcing a user in Japan to get data from Virginia, they can get it from a server right there in Tokyo.
So let's break down how this magic actually works. First, you tell the CDN about your origin. This is your single source of truth. Let's say it's an S3 bucket in Virginia. Then, the CDN uses its hundreds of edge locations. These are those data centers scattered around the planet to store copies. Now, when a user requests a file, the CDN is smart. It doesn't send them to Virginia. It automatically routes them to their closest edge location.
Now, here's a really crucial security tip. You don't want clever users to figure out your origins address and just bypass your fancy new CDN, right? That would defeat the whole purpose. So you set up something called origin access control. It's basically like putting a bouncer in front of your S3 bucket that only lets in requests that come directly from the CDN. No one else gets in.
So this whole system of distributed copies, how does it actually function? Well, it all boils down to one incredibly powerful concept: caching.
You see, any request is going to be in one of two states. The one you want is a cache hit. This means a user asks for a file and the local edge location already has it stored. Bam! It's served up instantly. Super fast. But what if it doesn't have it? Well, that's a cache miss. This first request is going to be a little slower, but it's actually a really important one-time setup step.
Let's walk through that first cache miss. Our very first user in Tokyo asks for, say, your company's logo. The Tokyo edge location checks its storage and says, "Whoa, I've never seen this before." So it makes that one-time long-haul trip back to the origin in Virginia to grab the file. But here's the magic trick. It serves that file to the user, and it saves a copy for itself. Now, every single user after that in Tokyo gets a blazing fast cache hit.
And get this, it's not just for static stuff like images and CSS files. Modern CDNs are also incredible at speeding up dynamic content, like your API calls. How? Well, instead of your user's API request traveling over the messy, unpredictable public internet, the CDN grabs it at the nearest edge location and sends it across the cloud provider's private, super-fast global network. It's like taking a private jet instead of driving in rush hour traffic.
Okay, so this all sounds fantastic, but it does raise a pretty important question. If we have copies of our files all over the world, what happens when we need to update something? How do we make sure our users aren't looking at old, stale content?
Well, our first line of defense is a setting called Time to Live, or TTL. And it's pretty much what it sounds like. You put a timer on your files. You're basically telling every edge location, hey, you can serve this file from your local cache for, say, this many seconds. After that time is up, you need to come back to the origin and check if there's a new version.
For instance, a really common TTL setting is 86,400 seconds. That tells every edge location around the world to hold onto a file and serve it locally for exactly 24 hours. During that day, performance is amazing. After that, the cache for that file expires, and the very next request will trigger a quick check back with the origin to get the latest and greatest.
But right, what about emergencies? What if someone uploaded the wrong company logo, and the CEO is calling you and you need it fixed everywhere, right now? Waiting 24 hours for that TTL to expire is just not going to fly.
So you've got two main strategies for this. The absolute best practice is file versioning. Instead of replacing logo.png, you upload a brand new file called logo_v2.png, and you just update your code to point to it. Since it's a new file name the CDN has never seen, it's an immediate cache miss everywhere, and everyone gets the new file. Now, for a true break glass in case of emergency situation, you can use a cache invalidation. This is a command you send to the CDN that says, hey, delete your copy of logo.png everywhere now. It works, but you want to use it sparingly because it takes time to roll out and can actually cost you money.
So after we've set up our CDN, locked down our origin, and figured out our caching strategy, what's the end result? Let's take a look at the after picture. And yeah, the transformation is just incredible. Well, you look at that. The load times for London and Tokyo have absolutely cratered, from 800 milliseconds all the way down to under 40. They're now just as fast as the local users in Virginia. That's it. The tyranny of distance is over. Our application is now consistently, beautifully fast for everyone, everywhere on the planet.
And this really brings us to the most important takeaway here. Building a fantastic application isn't just about having efficient code and fast databases. That's your compute layer. You also have to be completely obsessed with your delivery layer. That is, how your application actually gets from your server to your user's screen.
So we'll just leave you with this one question to think about for your own projects. It's so easy to build and test from your own desk and think, yep, this is fast. But in today's world, that's not enough. You have to ask yourself, is your application globally fast? Is it fast for all of your users, no matter where in the world they might be?